All right, writing equations in slope-intercept form. Let's go. Linear extrapolation is what we're going to start with today, even though this is actually going to be fairly late in the lesson. So, just put this in the back of your mind for later. Using a linear equation to predict values that are beyond the range of the data. So if they give us a chart that goes like this, but our last dot is here, they're going to say, what if it ends up being out here? That's really all they're asking. It's called extrapolating beyond the data that you have. Usually be like a year or something along those lines. If it did this from here to here, and this is 2015, what about 2018? That's going to be an extrapolation. Anyways, moving on. So write an equation given slope and a single point. So we're doing this with 1 point. So write an equation that passes through the line 2-3 with a slope of 1. Okay, so we're going to use the y-intercept by replacing m with, find the y-intercept by replacing m with the slope and using xy in the slope-intercept form and solve it for b. So it's really not that hard. It's just making sure we understand that we're putting in the information in we have into y equals mx plus b. Okay, so we take slope-intercept form. We're going to replace 1/2 for m. 1/2 for m. We're going to make y be -3 and x be 2. Be really careful on that one because, it's listed as 2, -3. I've seen a lot of students that all of a sudden, they'll switch these two because this one's listed first, and they'll put it here by accident, so they'll have 2 equals 1/2 -3 plus b. That is not correct. Okay, remember this is the y, this is x. Now if I could just write it correctly. Don't forget that. So you multiply those out. You subtract 1 from both sides, and that leaves b by itself. So now we can write our equation. So now we need to write slope-intercept form using the slope that we've given, or that was given to us, and the intercept that we found. So we take our slope-intercept form, substitute the things in, and that would be the equation they were asking for. Okay, you can also check it on a graphing calculator. You could put it in, use the calc menu, but we don't have those fancy graphing calculators, so we'll move on. Pause this, give it a shot. Okay, so we have a line that passes through 1, 4 and has a slope of 3. So I'm going to put it into my y equals mx plus b. So I know that it goes through 1, 4, so 4 goes in for y. My slope is -3, and my x is 1. Need to find b, so -3 plus b equals 4. I'm going to add 3 to both sides. Comes out to 7 equals b. Now we take the original information, y equals -3x plus, actually, minus y equals -3x minus 7. Oh, sorry, it was plus. My bad. Plus 7. Duh, that's a positive number. Moving on. All right, write an equation given 2 points. Now we've got two. Last was giving us 1 point and a slope. Now they're giving us 2 points and find the answer. Okay, so they give us our 2 points over here. And the first thing they want to know is which of these describes this function. So first we're going to read it. We know that the table represents these 2 ordered pairs. We're going to find the slope connecting the points using the slope thing that we learned, slope formula. There we go. So we punch all the numbers in. Remember, we need to figure out which one's which first. Punch those numbers in. Subtract, subtract. Remember, negatives turn to positives. So -8 plus 4 So it comes out to a -4 is our slope. Using that slope, we can choose one of those points and use the steps that we did last problem. So now we can take our slope-intercept form. We can put one of the points. It doesn't matter which point you choose. It should come out to the same thing. We put our points in and our slope. Remember, make sure you know which one's x, which one's y. We're going to then multiply it out. Subtract 12 from both sides. And simplify it out. -16 would be b. Still not quite done. Now we're going to write that using slope-intercept form. Here's my slope. There's my y-intercept. Punch those in. And we would have to go all the way back to our original question. And the answer would be D. All right, pause this. Give it a shot. All right, so we have to find which one of these describes the function. So we have to create this. Looks like a y equals -x plus b, or positive x. So we take our 2 points. We're going to put them in our formula. So we have y1 minus, or y2 minus y1, and then x2 minus x1. So I'm going to call this x1, x2, y1, y2. So I know which one's which. So 6 minus 3, rise over run. 6 minus a positive 3, yep. And then x2 would be 2 minus a -1. Those two come out 2. Looks like 3 and 1. That's interesting. So 3, 1 would be my slope. All right, that would actually be 3. 2 plus 1 is 3. So it'd be 3 over 3. So otherwise known as 1. So my slope is 1. Okay, so I need to find a y-intercept. So I need to take y equals mx plus b. I need to put my slope in of 1. Let's put a y coordinate. Let's do the bigger one. Why not? 6 equals, and then let's put 2 here. X is 2, so I'm using that point plus b. So that gives me 2 plus b equals 6 minus 2 on both sides. Give me 4 equals b. So punch it all in. Got a slope of, so here's 1, 2. Put it into my equation. Y equals 1x plus 4. Convert that really quick to y equals x plus 4. Bam. There we go. Keeping going. All right, the economy in 2005. Tim Costa's self-serve regular gasoline was $2.60. I wish. On the 1st of June and $2.82 on the 1st of July. Write a linear equation to predict Tim's cost of gasoline the first of any month using in 2005. Using 1 to represent January. So we're first going to, we know the cost in June, $2.60 in the June, and you know the cost is $2.82 on the 1st of July. So those are things I would be underlining. So we need X to represent the month and Y to represent the cost. So through this equation, we know that we have 2 points. We have the 6th month and the 7th month. For these two, and we're going to hopefully have a linear relation here. So that's why it says it is a linear equation. Fantastic. So first we find the slope. We take those 2 points. We punch them in. Comes out to 0.22. When we simplify that out, comes out to, and keeping going. So we choose a point, doesn't matter which one, and to find the y-intercept of the lines. So we take our slope-intercept form, we replace our slope with whatever we just found. We put x in for x and y in for y. Again, it doesn't matter which point, either of the two. Simplify, multiply that, subtract it to the other side, comes out to 1.28. So we write that in slope-intercept form, punching the numbers in, comes out with that equation. So that would be my linear equation for the price of gasoline. Could check it out if we really wanted to, which you probably should on a test, heads up. All right, pause this, give it a shot. Okay, same basic concept here. So in 1997, it was this much. In 2000, the average cost was this. Write a linear equation. If you estimate the cost of a textbook in any given year since 1997, so 97 is going to be my y-intercept number. That's what that's telling me here. So I just got to figure out what is the slope. Well, they gave me 2 points, so I would say that this would be 0 and 57.65 would be my first point. And my second point is going to be 3 years later. So it's going to be 3 and then 68.15. Sorry, that's 57.65. So we're going to call this y2, y1, x2, x1. Punch that into that equation. So 68.15 minus 57.65 over 3 minus 0. We punch those numbers into our calculator. We come up with 10.5 over 3. And it looks like they want that in a decimal form. Divide that by 3, comes out to 3.5. So there is my slope. My y-intercept is 57, which I already said. So I just put that in. Y equals 3.5. X plus b is 57.65. There we go. On average, Tim uses 25 gallons of gasoline per month. He budgeted $60 in gasoline for October. Use the equation to predict from X number, example 3, in order to determine if Tim will have to add to his budget. So we take the equation that we figured out in number 3 a little bit ago, and we're going to put in the month of October, which is the 10th month of the year. So we put 10 in. Simplify that out, so $3.48. So if gas increases at the same rate, a gallon of gas costs $3.48. 25 gallons at this price would be $87, because that's the question they wanted to know, is a budget of $80 going to be enough? So no, it is not. He will need to add that to his budget. Pause this, give it a shot. All right, a student is starting college in 2004. He saved $400 for his textbooks. Using the predictive equation of this one, where X is years since 1997, the average cost of the textbook, will this be enough for him to have for 5 textbooks? Y is the average cost of the textbook. So I guess they want us to do, just insert 5 in for X. So 3.5, and we're going to put 5 in here, because that's how many textbooks he has. Plus 57. Wait, that's not right. That's not going to work, because they want it in 2004. So 2004 minus 1997. It's going to be 7 years difference. And those will all cancel out after you borrow. So 7 years. So I actually need to put 7 into here. This will be the cost for 1 textbook, and we're going to have to multiply it by 4 after. So we'll see. 3.5 times 7 is 24.5 plus 57.65. Comes out to, so plus this, comes out to 82.15 for 1 book. We need to know if it's going to handle, if $400 is going to be enough for 5 books. So I'm going to have to take this number, times it by 5 books, And it comes out to 410.75. So no, it will not. That's all she wrote.